Good afternoon, everyone. Wonderful Saturday morning, afternoon, 12th, the 21st of December. This is our last webinar for this current year, 2024. And we are ending the webinar with wonderful subject, very important subject, a hot topic subject in the country. And normally we have the webinar on 11 o'clock. Today we are having 12. Only reason is we wanted our friend Peter from Poland to join. It's around 7:30 in Poland. So we wanted to accommodate his request to have it at 12 o'clock. So it's a good afternoon to all of you. And very good morning to Peter from Poland and Shyam from Chennai who's joining. And a very interesting topic, as ladies and gentlemen, the important subject that we're going to cover today is EV charging station testing and complaints as per IS, Indian standard, and IEC standard, with very special focus on the impact on power quality and grid stability. As we witness the transformative era in the adoption of electrical vehicles, ensuring robust compliance, high quality testing standards, and efficient charging infrastructure are critical to meet our global sustainability goal and ensuring seamless and integration with our power grid. Today's session brought to you by Sonel Instruments Pvt Limited, a leader in providing solutions for testing and compliance in the electrical and energy sector. So we are proud to contribute to this discussion about aligning with both Indian and international standard to ensure safety and efficiency and reliability. So why this webinar is important? You know that rapid growth of EV infrastructure, then there is a huge power quality challenges that comes along with that. And again, grid stability concern. So we will address these issues today. So this session promises to be insightful and interactive. We encourage you to participate actively. Put your question. We are having well-known international speaker today with us. So make sure that your questions are put it in the Q&A box only, not on the chat box, because chat box will not be able to record. It's my humble submission to all of you to post your question only in Q&A. And those who want to talk directly with speaker, once we finish the session, there is a raise hand button there below, raise the hand. You raise your hand, then I will go live and make sure that your questions are relevant to today's topic. Okay, please ensure that you don't deviate the questions or your queries related only to today's subject that we are going to answer. So I would like to introduce our two well-known speaker, Shyam, who holds rich 15 years of experience in electrical and testing and measuring in India and Europe, and is a master in electrical power engineering from WT Poland and certified professional in thermographer. He also published various technical articles, including CIRED in Sweden. So he's a familiar face in our electrical measurement and metering industry, and very young and highly talented CEO of the Sonel India. And we have our international speaker, Peter Pollock. He's graduate graduate of the Faculty of Electronics at the Warsaw University of Technology. He has over 10 years of experience in the Sonel Group, an experienced specialist who constantly implemented the strategy of building export market, both Europe and in the US. He has collaborated on many training and marketing and sales projects across the globe. So Peter actively participated in the implementation of new product. He collaborated on several new meter designs such as MPI 530 IT multifunction meter and the PAT 805 and 806 IT, portable appliance tester, and adjusting our product to the US market. In his spare time, Peter loves to travel and he loves India. He keep coming to India, and it allows him to meet new people and new places like me and like you. And I'm sure Peter will be frequent. And this is maybe third webinar that we are addressing from this platform of Blue and Gray. I want to thank Peter for joining from Poland today. With this, I want to welcome Sham. Sham, you need to tell us why this is so important, why this is so critical, and how Sonal is geared up to meet these challenges. Over to you. I'm going to stop my screen. Over to you, Sham.
Oh, thank you, Mr. Dominic, for this wonderful introduction. Once again, good afternoon to the audience. But as I know from the participants, we have good international registrations also. As I saw the registration, so a good day to everyone to start the event. I am joined by Mr. Piotr Pavlik, as he mentioned, from Poland. A good 15 years of friendship I have with Mr. Piotr Pavlik as a colleague and as a friend. So, the reason, the topic for the day, before we get into the topic for the day, I want to ensure that the audience, the speaker for the day, Mr. Pavlik, has a good experience on traveling in India. This year, at least, he spent at least 4 good weeks in India traveling around. So it's not only about an international standard or a technical representation. I am pretty sure that Mr. Pavlik has a good hands-on experience on the challenges that is faced on the ground reality in India today. That is very important because what we see on the standard and what we see on the infrastructure, how good can we deploy the good practices for our day-to-day operations is very important. As I mentioned, I know him for the past 15 years, so I'm pretty sure that his technical knowledge can help the audience in enriching their opinion about this total scenario. But I'm confident that we will move ahead very well in this session today. And I also wanted to make a quick shout out to another colleague who couldn't join today, Mr. Thomas Gavronski. Actually, he is an advocate of all this EV charging policies in our company. He was the first person to even inside our organization to bring this topic. I mean, couple of years before he got all our interest that we need to take this direction inside our company couple of years before. So a good shout out to our colleague Mr. Gavronski. Now, regarding the title for the day, the EV charging station testing and compliance. So, the title says we are majorly going to focus into the testing part, the electrical compliance part. That will be the major, the reason behind the session today. As the stat says, as you are all very well aware about it, the stat says in India the deployment is or the deployment of EV charging is already happening. As we all can quickly observe, it is majorly into the two-wheeler and the three-wheeler markets, majorly compared to the passenger vehicles and the heavy vehicles, let's say the buses, compared to this. So the deployment is already happening heavily on the two-wheelers. As I know, the stat it is about 1.2 million plus units are being sold in 2023, and the CAGR expected about a 40% growth until 2030. About the government expects at least 1.5 billion or something like is that as an infrastructure development that is planned for the years ahead. In the next 2 years alone will be a large investments in totality for the infrastructure. Now, quickly related to the Indian infrastructure, so we are expecting a major interest from the consumer market to get into this topic, and there will be a lot of audiences as a customer who wanted to enter into this. But like in any other industry, the first people who will come into this, we will call them as an innovative population. Yeah, it is highly important that we ensure there is a safe environment for this particular customers, because these are the customers who are going to advocate moving forward that yes, it is absolutely meaningful for the electrical vehicle adoption. Why I insist on the safety more here is, For example, a customer in US can have another feature like, for example, an autonomous driving car. But we know for a situation in India, maybe that is not an attractive topic, looking into the practical reality on the driving situations in India. More important for this customer is about the costing, about the climate change, about how reliable this infrastructure can be. So it is very important for all the companies included in this domain to address the safety in terms of the vehicle and in terms of the charging infrastructure at most importance, because the other elements which is given to the consumers outside of India is not actually given to a customer in India. This is what I personally feel about it. Uh, I wanted to also give out certain real world scenarios. For example, there are few industries in totality on this domain. For example, if there is a internal combustion engine vehicle which I buy, it is a very regulated market, I will say. If I own a Toyota vehicle, and when I purchased a vehicle, I was given that as per BS6 norms, you are supposed to follow this scenario. And if you have some problems like this, please come back to our showroom only to address this particular scenario. Yeah, so it's a very well regulated market on an internal combustion engine. But when we talk about a EV charging facility, let me give you the total companies who are involved in this. There is a vehicle supplier, and there is a huge dependency on the vehicle supplier for the battery, anything related to the battery infrastructures in totality. Then there is a charging station manufacturers. Then there is charging station infrastructure development companies, and there are also installation companies. We face this kind of scenarios. For example, an A grade contractor, or there are a lot of installations are being done by another set of companies. Then we have a power distribution company. As we know, in India, we have a power distribution companies autonomously maintained in every different province, where the regulations followed by these distribution companies are also slightly different compared to every other part in India. So you can't actually look into the scenario or the cost consumption on a top scale. It's that scenario is also not available. Then followed by that, there is an insurance company. Maybe that is common for both the scenario. Finally comes the customer. So in our topic related to the EV charging infrastructure, as a company, we actually traveled across India last year, and we met with almost all of these industries in totality. And in our discussion with these companies, we found one of the major scenarios: these ownerships are splitted. The vehicle manufacturer keeps the ownership on related to the safety or in terms of the infrastructure related to the vehicle. Then the charging station, I mean, everyone keeps their ownership only to themselves. And finally, then the question comes, okay, there are certain verification methods for the electrical charging infrastructure altogether. We have seen some accidents also in India in the last year. And in one conference I attended, it was a leading EV vehicle charger, I mean, leading EV vehicle manufacturer who launched some vehicle, and I was attending that conference. In that, the central minister used a very important word. One fire accident or one accident actually puts the aspirations of the government on a hold by a couple of months. The public adoption during that particular time is actually kind of slowing down. Once only when that scenario gets out of the public mind, the adoption again starts. So we have to respect the public who are getting into this adoption by a much more better charging infrastructure, in totality a safe environment for the user. So I'll give you some use case scenarios where, for example, where we are lagging. We have visited the charging unit manufacturing companies, and we identified, for example, the regulatory norms is if there is a electrical short circuit, for example, the protected devices should have an adequate coordination, and it shall trip. And you are having certain protected devices as per your design. It's your charging unit, it's your vehicle. You have made that kind of a design. Is it as per the Indian standard? And we found a major gap here is that uh, they have not tested. I can say at least 90% of the charging unit, whatever is there in India today, I haven't seen them tested at all in the past year. So we leave the infrastructure that is developed over the last year with a very limited testing, maybe okay 10, 20, 30, but we all admit to a fact that it is not being tested and there is no adequate coordination on the protective devices. The CA mandated regulation also insists that we must have an adequate protection. The lives are being lost just because of the factor that it is not being carried out properly. Then, for example, if we talk about when we speak to the customers related to this, the customers also insisted on another important problem. In India, we have a varying climate scenarios, for example, and the peak demand in the power utility also changes during this particular time. Do we have the voltage maintained in the grid as per the regulatory compliance? The question also lies over there. Now, keeping this infrastructure of the power utility, keeping this infrastructure of what we are deploying across the country, is it really safe? For example, if a fire, let's say a fire happens, the European regulation says you will have to have a thermal imaging inspection done to eliminate the fire as quickly as possible. But I do not know if any fire station units at all have this kind of methodologies of inspection. But we also see there is a billions of dollars that is going to be invested. We also see there is a millions of people who are going to get into this. Finally, okay, see, this is all the problem that we have. Why do we have to address this topic for India? At least for India. As per the news, I mean, even a couple of weeks before the news, we have reported a trade deficit. We have much more higher imports than the exports. And one of the key parameter in an import, obviously for India, is going to be crude oil imports. And independent or to some extent an independent infrastructure which does not affect our trade deficit will be an important element for the government policies. And we are talking about 1.4 billion people who are living here. We need to have a vision that these people will require a safe transportation scenario. So keeping all this in mind, we have some regulatory complaints already released by BIS and the IEC standards. So my colleague, Mr. Piotr Pavlik, will be addressing the technical requirements on how this verification is to be done. In my opinion, this is not about just another testing. The people's lives are at stake. And if we want to scale, the safety cannot be compromised. This is my initial observation. So I'll be the moderator for the day. I'll be happy to address to your questions. Over to you, Mr. Piotrek. You can enlighten with a bit more technical information on about the regulatory part, both in IEC as well as the Indian standards. So please do post your questions as Mr. Dominic commented on the Q&A sessions. We will address the questions by the end of the presentation. So over to you, Mr. Piotrek.
Okay, so hello everybody, and it's nice to be here again. So today I'm going to talk about the safety check and the performance check of electrical vehicle charging stations. Well, we are going to start with the safety. So, well, first of all, when we have the charging station, we need to remember that this is not like a standalone thing. It is somehow connected to the grid. So from the grid, we have the transformer, meter, panel, and then we're going to connect the charging station, or we are going to have an outlet, and then we are going to charge our cars through that. Okay, so what are the requirements? Well, first of all, we have the safety requirements of the Central Electricity Authority. Here, Chapter 11 specifies the safety for electric vehicle charging. Further on in the NEC, well, it also specifies the safety of electrical installations. And Part 3, Section 15, this one is dedicated to electrical vehicle charging. Also, there's a standard, so Indian standard 17017. This is about electric vehicle conductive charging systems. So let's say these are the most important, requirements in India. Well, still, let's remember about the IS 732, which describes the safety of electrical installations at all. And further on, we have the international standards, like the IEC 61851 describes the modes and methods of communication. Then we have IEC 62955 and 62752, which describes the residual current devices. Plugs, sockets, and connectors. This is the IEC 62196. And the IEC 60364. Here part 7-722 describes the requirements for special installations that supplies for electric vehicles. So let's just say, to simplify, the entire grid that will be the safety regulation of the CEA, NEC, and IS 732, and specified for the charging stations that will be the chapter 11 from the CEA, from NEC part 3 section 15, and IS 17017. All right, so these are the standards. Now let's look at the methods of charging. So, first one, we can just use a cable and connect our car to existing socket. It could be a single phase or a three phase. And mode one, that was the cable without any breakers. So this method is right now obsolete, as right now we have mode 2. So you can see that there are breakers, RCDs on the charging cable. Now, mode 3, this is when we have AC charging stations, and there are a few cases. Case A was when a car had a permanently fixed cable. Again, this is obsolete these days. These days we would look at case B or C. So B, this is a charging station with a socket, and car owner, they have their own cable. And case C, this is when the AC station has a fixed charging cable. And finally, mode 4, this is the DC charging stations. The type of connector that we are having in India, and by the way, also in Europe, this is called type 2 connector, and this is how it looks like. So for the AC charging stations, that's how they look like. We have control pilot, proximity pilot, ground channel, and then phases and neutral. And in case of DC chargers, again, we have here on top control pilot and proximity pilot, ground channel, and down below we have DC plus and DC minus channels. So for the AC charging, these are our options. We can connect the car using special cable with the breakers directly to the socket. It could be single phase or a three-phase socket. And then we have charging stations. The one here in the middle, this is a charging station just with a socket. So the car owner needs to bring their own cable. And the one on the right, this is charging stations with permanently attached charging cable. And for the DC chargers, they always have permanently attached cables, and that's the plug that we are going to connect to the car. Okay, so those were different types of chargers. Now let's look at the test that we need to perform. So let's start with mode 2, when we are just having the cable that we will attach to the existing socket. So here for the cable, the measurements, as you can imagine, we are going to check the continuity, insulation resistance. We are going to check the RCDs on this cable. And in case we have a three-phase cable, we can also check phase rotation. As per diagnostics, we need to check different methods. So the control pilot, different states A, B, C, or E. So simulating no connection, car connected without charging, charging, or error. We also can check for different levels of currents and perform signal diagnostics for the control pilot and transmissions through different states. We can also simulate faults, so breaks in different wires, replaced cables, voltage on P, or fault simulations in a case of communication. Now, as per mode 3, when we have AC charging station, so for the station itself, whether it has a socket or attached cable, we need to measure fault loop impedance, RCD parameters, including DC leakage current above 6 milliamps. We need to check insulation resistance, continuity, phase rotation for the three-phase charging stations, and in case they have their own earthing, we also need to check earth resistance. Diagnostics and fault simulation just same like for the cable. But further on for the mode 3, in case we have this situation, so charging station only with a socket, also it will be good to check the charging cable. So here we need to check its continuity, insulation resistance, and the coding resistor. And finally, for the DC charging station, we need to remember that the charging station is connected to the AC grid. So the DC charging stations, they have the AC part and the DC part. So for that all reason, we need to check fault loop impedance, insulation resistance, RCDs, phase sequence test. We need to check continuity here with 10 amps test current. And on the DC charging stations, we are going to have surge protection devices, which we also need to test. And in case the station has its own earthing, we will also need to check earth resistance. All right, so these are different measurements for different types of stations. And now let's see all of the measurements that we need to perform. Of course, the applicable ones to appropriate charging modes. So first, we are going to do the visual test and diagnostic of control signals. So with the visual test, we are going to check with our eyes and appropriate senses if all the equipment is installed properly, if there are no loose connections, and there's also a big list of different elements, not necessarily connected with the electrical part, but to check, for example, the protection of the cover of the entire station to make sure that there is no water inside. There should be some barriers preventing the cars to drive on the station. We don't want to hit it with the car, and so on. But yeah, there's a whole list. Then, as it comes to the check of the working of the station, we need to check the control pilot, and here different positions, checking for no connection, connected without charging, connected with charging for stations with or without ventilation, and error. Also, we can check different levels of the currents. Now, here you can see, for example, the picture of the display of our meter called EVSC 100. So that's the meter dedicated for checking safety of the charging stations. And here you can see different levels of the current for the proximity pilot, different states for control pilot, as well as we can check the levels of control pilot plus and minus. And we can check the signal filling over here. Now on the meter, you will just find a big checklist for all of the visual tests. And by pressing appropriate positions, we can say that they have been tested and passed. Next test, this is the continuity of protective conductors. And basically, this is a pretty easy test. We connect on one end of the conductor, on the other end, and then the meter is going to check the resistance. So it will check the resistance of the test leads together with the part of the wire that we are interested in. So before that test, we need to remember to auto-zero the test leads. So then the meter will calculate the resistance of the test leads themselves and deduce them from the overall result, giving us just the result of the part of the wire that we want to check. And here we need to check this continuity with forward current flow, with the reverse current flow, and the average of that will be our result. Just we need to remember that in IS 17017, it says that we need to check continuity of the charging stations with at least 10 amps. Well, yeah, so this is the requirement here. Okay, next test, this is the insulation resistance. So here, oh, not too far. Okay, so here, well, we have a table giving us what should be the test voltage and what's the requirement for insulation resistance, depending on the nominal voltage of the circuit. Well, in most of the charging stations, we are going to have this situation, so up to 500 volts, and we are going to test this with the 500 volts DC test voltage, and the insulation resistance should be above 1 mega ohm. So here with our meters, well, depending which meter you are going to use, but you can select what configuration you want to check. So different between lines, line to neutral, line to line. And then the meter will just make all the tests in a sequence and give us the overall result at the end. So that's a convenient way. Then next thing that we need to check is the effectiveness of electric shock protection. So if our overcurrent breakers are working, and for that reason, we are going to check fault loop impedance. So how does it work? When we have a fault somewhere in the circuit, then we are going to have some potential on the cover. And we are going to get rid of this potential through the PE channel, so either directly to the transformer or through the ground, or through a body of some poor guy that is touching the cover of this charging station or other accessible conductive elements on the cover. And all of these currents together, they create a fault current. So this is a current flowing through the ground in case of a fault situation. And the whole idea is that fault current should be higher than current triggering the breaker. So this is pretty obvious. We have overcurrent protection. So in case the current flowing in case of a fault is higher than the limit of the breaker will work. And this way, you know, the people are safe, and will also prevent any overheating or fires. Now, we are unable to measure directly fault currents. So for this reason, we are measuring the impedance of this fault loop. And we know what is our supply voltage. And then voltage over measured impedance will give us the value of fault current. And then with our meters, we can perform this measurement. We can also enter on the meter what type of breaker we are having. So then the meter will calculate for us the fault current and will compare it with the triggering current of selected breaker, evaluating the result for us. So everything will be in green if it's okay, and in red if the result is negative. Okay, then next measurements that will be RCDs and RCMs. So here, how the RCD is working, the device is powered through a phase channel or channels. Returning current is on the neutral channel. If those currents are about the same, then the RCD is not going to work. But in case we have some leakage currents, some residual currents flowing through PE channel or through any other way, then there will be difference between current on the phase and the neutral channel, and the RCD is going to work. So the parameters that we can check here will be the value of this residual current, the disconnection time, touch voltage, so voltage to ground, or resistance to ground. And we have different types of RCDs. There's the AC type, which works just with the sine wave current. Then we have A type, which works with the current in the shape of a sine wave or pulsating DC, up to 6 milliamps. Then we have type F, which works with the sinusoidal pulsating DC and a composite of multi-frequency up to 10 milliamps. B type works with sinusoidal, pulsating DC, smooth DC, and composite of multi-frequency up to 1 kilohertz, and B plus up to 20 kilohertz. Now, as you can imagine, the battery in the car gets charged with the DC currents. So there's somewhere a rectifier on the way. It could be either on the charging station, if it's a DC charging station, or inside the car. But anyway, the shape of the charging current is not going to be a nice sinusoidal one. So for that reason, for charging stations, we need to use RCDs type A, F, or B. And furthermore, in the National Electrical Code, we can find this information that the charging stations should be secured either with RCDs type B or with RCD type A with additional protection against DC leakage currents above 6 milliamps, or with RCD type F, again with the protection as per IEC 62955. So now we are looking into the IEC, and this describes us the RCDs that we should use for mode 3 of charging. And further on, there's even one more in case we have the RCDs embedded in a charging cable. So that's for the mode 2 of charging. Then we'll look into the IEC 62752 to make sure that our protections will work for the DC leakage currents above 6 milliamps. And here, as per these standards, we can see how we need to check the breakers and what would be the maximum values of the times for multiplication of the nominal current. Okay, so we can check it on the meters. We can select what type of RCDs we are having. We can check disconnection times for different values of nominal currents, different multiplication of nominal currents, as well as the disconnection current. And at the end, we will have all the results on the meter. Next test, that will be the surge protection devices. And here we can see one. So this is how it works. We have one input here on the phase channel, one on the ground channel. And basically the surge protection devices are used to put both lines on the same potential in case of some surge. Especially this is useful in case of a thunderstrike. So we have different types of the SPDs. Now, as per here DC vehicle chargers, we are going to use the type 2. So they are treated, the chargers, similarly as sub-distribution boards. Now we are going to connect the meter plus test lead to the phase terminal, minus test lead to the earth terminal, and we are going to start the test. So we can check the AC voltage at which the protector breakdown is going to occur. And also we can check this with the DC voltage. Okay, next test that will be the phase rotation. So this is for the three-phase charging station. Well, obviously the rotation needs to be done in a proper way, or it could be in an opposite way, then the meter is going to show us the negative result. And the final test, this is only for the charging stations, which has some earthing of their own. We need to check its earth resistance. So, for example, here I'm showing the three-pole method. So we need to disconnect the earthing from the charging station and create the measuring circuits using two rods to the earth. Further one, this is the current rod. So this will be the current measuring circuit. Closer one, S, this is the voltage rod. So this will be the voltage measuring circuit. And then voltage over current will give us the value of resistance. Of course, we can use also other methods like 4-pole, 3-pole with clamps, or 2 clamps method. And in case the charging stations is, if they are in the garage, in some building, then we just need to make sure that the earth channel of the charging station is connected to the earthing of the building. Okay, so these are all the safety tests that we need to perform. Conveniently, with our meters, we can create the automatic sequence. So then you connect them to the charging stations, and they will perform all the tests in the sequence for appropriate type of a charging station, and give you all of the results summary at the end, like you can see on the screen here. Okay, so let's look what type of meters we need to use. So if we would like to check the entire electrical installation, we can use a multifunction meter of the MPI series. And for the charging stations, we are going to need EVSE01 adapter for that. Now, as we are going to check just the charging stations, we can use the EVSE100 meter. Now, for the DC charging stations, we also need some meter for checking SPDs. Here, well, for example, I can suggest insulation resistance meter MIC 2511. And to check continuity with 10 amps current, we're going to need a micrometer, well, at least the model MMR 640. Now, further on, in case we would like to check transformers, then we're going to need more powerful single function meters, like one for earth resistance, one for insulation resistance, one for fault loop. Okay, so let's quickly look at our meter. This is the one dedicated for checking charging stations for electrical vehicles. The model is called EVSE100. And actually, it is still a little secret, but it will be released next month. So we are waiting for that. And this is how the meter look like. Here, this is charging of the meter. Here we have the fuses. Then we operate the meter using a touch display or buttons underneath, or we can operate it remotely using the app on the phone or the tablet. To connect it to the charging stations, we have different sockets. So either a single-phase socket, three-phase socket, or a socket with a type 2 outlet. We can also check the leakage current over here on this wire. We have external, well, output to external oscilloscope. So in case we would like to more precisely check the control pilot signal. And we have some ports for the communication, like the USB or LAN. Now these are the, I was showing here you the in sockets for the cable. What about the out socket? It is outside, like you can see over here. And furthermore, in standard, this meter will come with adapter called AEV100. So when we put it into the out socket and we connect the test leads, like you can see here on the picture, it is going to work similar to the multifunction meter, which can check different parameters of even regular electrical installation. Okay, so what this meter can do? Well, what's the significance? Well, first of all, I know that many manufacturers, they have adapters for checking charging stations. So you need some base meter and then you buy adapter and then they can work as a set. But here the EVSC 100, this is the standalone meter. So you just have one unit and it's good for checking different types of charging stations. And here it can simulate different current levels on the proximity pilot, different states of the control pilot, so A, B, C, or D, and different errors on the control pilot, like you can see here on the picture. Now further on, for checking different errors, different faults, we can check breaks on different circuits, we can check interchange channels, and we can check voltage on the PE circuit. And as it comes to measurements itself, we can measure fault loop impedance, we can check RCDs and RCMs, so together with this requirement for DC leakage current over 6 milliamps. We can check insulation resistance, we can check continuity, however here with the current of 200 milliamps, well, the whole problem is that still worldwide the norms are not the same in different countries and they are still developing. So, well, for example, in Poland we need 200 milliamps to check the continuity. In India, the Indian standard requires 10 amps. I think in Germany it requires 10 amps as well. So the norms worldwide are still developing. So that's why we're going to need another meter to check continuity. Now, further on with this meter, we can check earth resistance using free pole method. We can check phase rotation. We can check voltage on the control pilot channel on both plus and minus, as well as the signal filling. So it has a small oscilloscope there. We can check frequency and the off time of the station. And also the useful thing is that we can operate this remotely. So we can just come with this meter in a box to the charging station, connect the charging station, and perform all of the tests remotely, even without opening the meter. Okay, the next solution, this is the EVSC01 adapter that we can use with our multifunction meters of MPI series. And the adapter is just the interface between type 2 connector and the meter. Of course, the measurements here, they depend on the capabilities of the meters, but we recommend MPI 535, 536, 540 or 540 PV for that reason, because we can check the RCDs and RCMs in the charging stations. I know that the older models, like for example MPI 520 that we developed was it like 15 years ago, it cannot check the DC current for DC leakage current of 6 milliamps. So that would be a limitation for some older designs meters, but the newer designs, they can perform all of the tests, give you the summary from which you can create the report. Okay, so now let's look at the application. So this is what I can imagine. We can have like two types of test electricians. One will be responsible for the checking of the infrastructure. So we are checking everything that is permanently connected to the grid. So the sockets, AC charging stations, or DC charging stations. And for that reason, we are going to need the set of the meters, which will be the multifunction meter with EVSC01 adapter, micrometer with test current of at least 10 amps to check continuity, and for checking SPDs, the insulation resistance meter, which has such capability. Or we can use the EVSE 100, again, together with a meter for checking SPDs in the DC charging stations and the micrometer for checking continuity. Now, optionally, in case the charging stations is very close to a transformer, we will expect the fault loop impedance to have very low values. And in such situation, we will need just a more precise fault loop impedance meter, like, for example, here, MZC320. But let's say this is just optional. It all depends on the, well, circumstances and the design of the network. Okay, now another application that will be when we are checking the vehicles, so different garages, repair stations, then they will be checking the vehicle and the parts that are that come with the vehicle that are just properties of the vehicle owner, like charging cables. And here the best solution to check the charging cable will be with the meter EVSE 100, as we can connect the cable on one end, on the other end, and then perform all of the tests quickly. Okay, so those were the safety electrical checks. One more thing that we need to check is the light intensity measurement. And here we have the standard IEC 12464, which requires to check light on the refueling stations. It does not specify what type of fuel is it. Is it gasoline? Is it electricity? Is it something else? It just says that the meter reading area should have 150 lux. So that should be the light intensity in the meter reading area. And we can perform such tests either with our multifunction meters using the additional optional light measuring probe, or using our lux meters. Then we're just going to face the probe towards the source of the light, make the measurement. Here you can see example of the result. And that's it. And later to perform the report. So from all of these meters that I have presented to you, we have software called Sonel Reader, which is a free software. It allows you to download data from the meter, process them, and export to Excel file, text file, HTML file, or PDF file. Or we have chargeable software called Sonel Reports Plus, which allows you to download data from the meter, process them, and create a report as per standard. Okay, so those were all of the safety checks, but now let's talk about the performance and the diagnostics. So the power quality. Now, there are different standards defining the quality of the power. Well, for example, in Europe, we have EN 50160, which defines the quality of the voltage. There's also international IEC 61000, which is a multi-sheet standard describing the emissions, for example, of higher harmonics into the mains, limitation of the voltage fluctuations, and flicker. There are also IEEE standards like 519 regarding harmonics, 516 regarding the power quality. And in theory, the chargers should be designed in a such way that they do not significantly interfere with the main supply. However, electric cars are powered with DC currents, as we're talking about their batteries. So therefore, charging is done with the direct current, either from the charging stations or from the rectifier inside the vehicle. And in both cases, there are power electronic components involved with non-linear character, and they can cause some interference. So we need to make the diagnosis. So, well, the impact on the chargers on the main supply, we can check here a few different parameters. First one, that will be harmonics in current and voltage, well, together with the THD. So rectifiers, regardless if they are in the charging station or in the car, they usually generate harmonics by drawing a distorted current. As you can see here on the picture, so it is not a nice sine wave if it is distorted, and these are the harmonics. If the harmonics in a power system exceed the limit set in the regulation, it may be necessary to disconnect the problematic charger, which will certainly cause frustration to the users. But we need to remember that the presence of voltage and current harmonics is natural consequence of the commonly used electronic devices. So it is worth checking their level even before installing the charging station. And in case of high harmonics content in the voltage, it may turn out that after connecting the chargers, the limit may be exceeded. So even if there are not, higher harmonics level can cause various negative effects in the mains, such as overloading the neutral line, poorer performance of devices, vibrations, or difficult startings of the motors connected to the mains. The next thing that we would like to check will be unbalance. So if we have a three-phase charger, well, this problem should not exist. But when we use multiple single-phase chargers with higher power outputs, this can result in unbalance of currents and voltages. Even if the chargers are installed in different phases, it may not be possible to force all of them to work at the same time at the same load. So this will result in a certain level of unbalance, which has a negative impact on the three-phase consumers, causing, for example, higher energy consumption and increased heat loss in motor windings, which shortens their life. Next things will be voltage dips. So when we have higher power chargers, they will cause voltage drops in the mains, which may cause a number of problems with functioning of devices in conditions of reduced voltage or cause decrease in their efficiency. In addition, in extreme situations, the permissible voltage level set by regulations may be exceeded. So when we connect a lot of loads at the same time, the voltage may drop. Also, when we connect bigger loads, we need to look at the powers, and there's active power and reactive power that we are concerned about. So for the reactive power, the chargers as converts, it generates capacitive reactive power in most of the cases. Since excess reactive power is not desirable, the exceeding of the contractual value with the power utility may result in some financial charges and fines. So it is worth to control the level of the reactive power. And as per active power, assuming that the peak demand has been measured before the charging stations was installed, and we know what is our capacity, it is worth to carry out the test again after the charging station is installed. And with time, more consumers may be connected to the mains, which may cause problems with power supply efficiency. So these are different, let's say, factors that will affect our grid, and we can check it using power quality meters. And here at Sonel, we have a few options. One is the PQM 750, which is a permanently installed meter. It's a full Class A power quality analyzer. And you can imagine this, for example, when you are owning many charging stations, you are owner of charging stations, you can put on your transformers such meters. And you can connect this to some sort of your managing systems, like some SCADA system, and then constantly, permanently monitoring what is going on with your charging stations. And thanks to this, you can quickly solve different problems with malfunctioning equipment. You can prevent failures of equipment. So that's a useful way to monitor the stations. And in case you are facing just some problem with a single station and you want to come diagnose this problem and then disconnect your meter and leave, then we have portable power quality analyzers like PQM 700, which is a class S analyzer, PQM 710 or 711, which are class A analyzers. We can leave them for some time to monitor the quality of the power in the network. For example, we can leave them out for 1 week, then take them down, read recorded data from the meter and diagnose the problem. Also, we have PQM 707, which is a class S analyzer. It has embedded large display, so here we can connect it and see live different graphs, different parameters, what's going on. It is also capable here of recording over a period of time. Well, however, the protection of the cover is better on PQM 700 or 710, 711. They have IP65 and PQM 707, it has IP51 of the cover. So if you want to leave the meter outside and it may rain on it, there could be dust around, then PQM 700 or 710, 711, they are just protected in a better way. Okay, and let's say those were the chargers, but one more thing that comes to mind talking about electric vehicles will be the batteries inside the vehicles. So again, we are coming back to some service garages. Here, when we are doing check of a vehicle, one of the elements that we are going to check will be the battery. And here we need to perform the visual test and some electric tests of the batteries, like the test of the impedance. You might want to ask why not resistance, because the batteries is just DC. But as the battery is aging, they just don't tend to keep the level of their voltages and currents. So they may fluctuate and they will have the AC component. So for that reason, we are checking impedance and not the resistance, as well as the float voltage, float current, ripple voltage, ripple current. So voltage DC, voltage DC voltage and current, AC voltage and current. We can check temperature, capacity, so charge or discharge test. We can check the continuity of the string of the batteries and the intercell resistance. And for that reason, at Sonel, we have a battery tester called BT 120. So that's the meter that allows you to perform all of these tests. Okay, so I got to the end of my presentation. I have shown you the tests of that we need to do to check electrical safety of the charging stations. Of course, different charging stations, different types of tests, different meters that we can do this with. Performance, so here we are talking about the power quality. I just, touch the bases here on the main power quality phenomena that can occur from the charging station. And finally, for service garages, we can use the EVSC 100 meter to check charging cables and the battery tester to check the batteries in the cars. Okay, so thank you very much for that.
Thank you, Piotr. Thank you for this insightful presentation. If you don't mind, we can quickly go through the questions in the Q&A session. You can look, there are about 13 questions that is asked. If we can go through the questions, it'll be of a great help. think the first question is extinguishing media for batteries, whether water is suitable. Okay, they are talking
Uh,
about the fire and the 1 and 3. I think it is similar. Yeah.
I think as for extinguishing, water is not suitable. There's some special foam, but yes, we are talking about we are talking here about the electrical safety. The extinguishers. I'm not that familiar with this, but I know that this is also interesting subject, and that fire brigades, they need to be equipped with a special some devices or foams or materials for extinguishing fires. But I'm just not familiar that much with the fire, more on the electrical part.
Fair enough. Let's go into the next question. How to check the touch current in a three-phase charger? If per phase is 18 amps, I mean, it's an 18 amps. So, if there any instrument to help the touch leakage current,
Um,
leakage current means.
yeah, okay. So here I think we are talking here about the fault loop impedance measurement, because the touch current, I mean, when I touch the cover of the charging stations and there's a fault, something will flow through my body. This is the fault current. Yeah.
Yeah.
So when we are measuring fault loop impedance, we take the voltage, the supply voltage, we divide it over the measured value of impedance, and we have the value of fault current. And now if a fault current is higher than current triggering the breaker, then everything is okay.
Okay. Do we have any instrument? A question from Mr. Ashish Manchanda. Do we have an instrument? Do we have any measurement possible to see the EMIs as per IEC 61000? I think they're talking about 61004-30, but related to the EMIs.
Here the IEC 61000, it's a big multi-sheet standard, and it defines levels of disturbances that certain devices can lead into the grid, and the level of disturbances that the devices should be resistant to. And there are also home devices, industrial use devices, so there are different levels. Okay, and here when we are talking about the charging stations for electrical vehicles, as they need to be resistive, immune to different signals coming from the grid, that will be on the part of their manufacturers. And in the factories, they have some equipment to check this. But as we have already installed station, we need to check the levels of signals that it can introduce to the grid. And for that reason, we have the power quality meters. So meters of PQM series, PQM 750, that's the permanently installed one. So we can put it, for example, install it in a transformer next to the charging stations. And then we are going to see what are the levels of disturbances coming from the charging stations.
Yeah, so you're suggesting a continuous monitoring of.
Yeah, we can do that. I mean, this is a good idea, but we can also, for example, when we have complaints from our neighbors, neighbors in the electrical network, that they have some problems with the devices, then we can send over a guy with the portable power quality meter to put it on the chargers and check what's going on there, if there is a problem. I mean, permanent monitoring can help us constantly see what's going on in the network, see the problem once it's at the moment that it is occurring, and prevent failures as we are analyzing the historical data. So we can just schedule some maintenance when we see any problems.
Sure. As per the CA notified guidelines in India, it is to monitor continuously the power quality. It is already there in the notified regulations of CEA's website. So what you're saying is already given as a notification from the Indian Regulatory Authority. So I do agree with your statement here. Let's get into the next question. Is a simulator suitable? Is a simulator used in the compliance testing? I think the compliance testing, Mr. Hemant is referring to the standard verification. Yes, it is what you are suggesting. Can you, is a simulator used in the compliance testing?
I think we're talking here once we are building the charging station to make sure that it fits the standards.
Yeah, so that's what we were referring to, all the standards. Okay.
Well,
Let's move
yeah, I
on.
mean, if we're talking here about the CA regulation, NEC IS 17017,
Yeah,
further to the
that,
grid IS 732, yeah, we can do that. We can use that meter.
that is all the compliance regulations as per the local regulatory body. Yeah. So how to do the accuracy? Oh, this is an interesting question. The question is how to do the accuracy test of a revenue meter using EVSE 100. Whether any pulse inputs is available. When there is a revenue checking going on, how do you do the revenue testing?
Well, okay. Well, revenue. So we are talking about, meters that check kilowatts hours and then convert this to the money. Yeah. Okay. So those are the meters permanently. The energy flow meters are permanently installed in the charging stations, and they are just a part of the charging station as a thing.
Yeah.
But if we want to check the accuracy of those meters, I guess that we will need to send to some laboratories.
Yeah,
That's
Mr.
not
Sunil,
the part of the EVSC 100. They do not check the revenue meters. We need to get the revenue meter, send it to the appropriate laboratory.
yeah, I think it is about the calibrators or the calibrator laboratories we are talking about. We'll contact the customer after the seminar with some other information for it. Okay, because your session was majorly into the electrical verifications. Okay, the next question is from Mr. Etella Narendra. Are these tests were included in the CIEG inspection, that is the State Safety Inspector Department? If so, which regulation of CEA is to be referred? They're asking against which CA regulation are you referring?
Hold on.
It is, I can answer CA Safety Standard 43. And if you talk about CA regulation, notified regulations under CA, you will find those CA regulations. CA safety standards will talk about electrical fault loop impedance in the recent the safety standard that was recently released in 2023, where they insist about electrical fault loop impedance that is to be measured. So the automatic disconnection of supply is mentioned in that regulation. Correct me if I'm wrong, Piotr. We discussed about the CA regulation before.
Yeah, that's the one.
Yeah, the safety standards. Okay. The next question from Mr. Hemant Ranawat. EVSE 01 is available with accredited calibration. So it is like, is it available with an accredited calibration?
Okay, so here the EVSE01 is just adapter between the multifunction meter and the type 2 connector on the charging station. So we're going to need calibration certificate for the meter, not for the adapter. And well, we do have at Sonel, once we are manufactured, we have the accredited laboratory with the ISO 17025. I think in standard, I mean, you need to check this with the salespeople, but I think in standard, they do not come with the calibration certificate with accreditation, but this is available as optional. As an option when you purchase that. So we can put this through the laboratory, get the calibration certificate with accreditation.
Okay.
So then this certificate will be either for the multifunction meter of the MPI series, which comes with the EVSE01 adapter, or for the EVSE100 as it is a standalone meter.
Okay. So which means if a customer is requiring, we will be in a position to do it. Yeah.
Yes.
So can you show the video of how to, I think this is about the energy logging meter, the customer have typed it. Can you show the video how to do the accuracy of the connected energy logging meter? The previous question, what we discussed before regarding
Okay.
calibration of the equipment. We discussed, yeah, like how do they do the energy logging meter? So we'll go to the next part because that is about the calibration, which we will, I mean, from Sonal India, we'll contact the customer and answer the questions. Okay. Very good presentation. Thank you. Do we
Thank you
need
very
to
much.
take any license to measure these parameters? If so, from which department?
Okay, we're talking about the electrical license of the person to do that. Well, yeah, definitely the electricians needs to be licensed. You cannot just, just go and work with electricity without knowing anything. I'm not entirely sure who gives the licenses to electricians.
We have the departments in India who gives the licenses of different works. For example, to do the installation, we there is A grade contracting licenses who does the installation. So yeah, there are different licenses to carry out these activities on electrical EV charging installations, etc.
Yeah, and there should be, I think, at least a chartered electrical safety engineer.
Exactly.
Yeah. So at least that, or if some companies employ, they could just have electrical safety engineer without chartered. Chartered is like the contractor for.
Yes. For this measurement on safety circuits, maybe Mr. Dominic can also come in. Mr. Dominic, if you're there, we are giving this licenses on fault loop impedance measurement on certification. They do this certification program from NFE, where they are doing the educations and training for such kind of measurements from NFE. So, okay, if Mr. Dominic is not there, we'll move into the next question. Can we get the case studies from your site? Yes, absolutely. You can contact us. The mail IDs are given to us, sir. Definitely, we will share you some of the case studies. We do this on a periodical basis. We will be in a position to share you case studies, and we can organize a session maybe after a couple of months with a bit more case studies that we collect from India. Piotr, will that be comfortable to you to make another session collecting more, site conditions or the reports from India, and we can conduct only a session about the reports from India. Will that be comfortable to you?
Yes, I think so. I mean, still we need to release the EVSE 100.
Yeah.
And we need to do some measurements with this. And then with those information, we will have some case studies.
Yeah, and I think it is very interesting because we have a peak summer during April and May. If we continue this continuous power quality monitoring along with the EVSE safety audits in some locations, we'll have very good information to conduct a session only about the findings. Maybe by the month of May or June, we can collect all the informations from the site and we can have a session because the peak summer can happen during April and May, where I presume there will be a different demand situation from the distribution company.
Yeah.
So I think the next question.
One more thing I want to show you here, our website, so sonel.com. If you go to Knowledge Center, press articles, and there was one about power quality on the charging stations.
Yeah.
This was basically what I was talking about. Oh yeah, here it is. So chargers for electric cars can then deteriorate the quality of power supply. Well, this is what I slightly talked about today. I took some parts from my presentation from this article, but here you have like a case study what can happen with the chargers.
Sure.
Also, in case you would like to see the use of our meters, you can go to YouTube channel, Sonel, and on our YouTube channel, Sonel Measurement Instruments, you can find videos showing you how to use EVSE01. Oh yeah, there are many languages here, but you can find the one in English, and it shows you how to use the meter. So it's also a sort of operation, yeah, maybe more operation help.
Sure. I think the next question is very much similar to the PDF what you showed, a very interesting question from Mr. Ankur Sangpan. I'm from a distribution company looking after the network designing and planning. So he has two queries. Impact of reactive power due to EV charging. Any significant impact or compensated by the EV charging stations? Please suggest key points which can be considered during the network planning for next 3 to 5 years. What is your suggestion?
Yeah, so when we have the reactive power, well, this is the power that is not used, but it can create some unwanted effects further in the grid, even with burning some transformers. But I'm just thinking typically, distribution companies allow certain levels of reactive power. And if this level is exceeded, then there are fines to the consumers. So the consumers want to keep reactive power below the maximum level.
Yes.
So that would be the biggest part here. Also, I'm thinking from the point of distribution company, I'm thinking it can just overload the transformer. So that could be the trouble here. And the key points, so here I'm just thinking about some standards on power quality so that the reactive power wouldn't exceed the levels, or any internal regulations of your company. So also we would keep the reactive power below the up to safe level, so it wouldn't exceed the safe level.
Sure. Here in India, if we talk about the levels, majorly we are talking about the harmonic levels. Before we had a THD, and some of the provinces are already talking about total demand distortion, TDD, shall be maintained below the percentage. Before THD used to be 8% for the current harmonic distortion. And if we talk about the regulatory complaints, majorly it is about the impact of harmonics is what is the question. I mean, is what is the scenario we have? Yeah. Okay, so let's get into the next question. Maybe after our findings, we can contact or conduct a seminar very clearly about how was the reactive power situations in India, which we will collect it during the next few months in India, and we can share a session accordingly. Okay. Next is an interesting question, Piotr. Is there a correlation between SPDs and the harmonics?
Yeah, in the IEC 61000. Okay, well, surge protection devices, there are to protect connected equipment from any surges in the voltage. Like, for example, when we have a thunder strike, it's going to be a big surge. So there are just the protection here. I know that manufacturers of the SPDs, they have certain requirements here, but as we are not manufacturing the SPDs ourselves, I'm just not familiar with that.
Okay. Can we get into the next question? What is the right instrument to be owned by a consultant or a contractor for two-wheeler, four-wheeler, EV buses, charging station? I mean the code of the instrument.
Okay, so here when we are with our instruments, we can check the charging stations which connect, because I know for the buses sometimes there are inductive charging stations. So here when we have permanent connection, That would be either EVSE 100, which is a standalone meter, and you can test all the cables, so mode 2, all the AC charging stations, so mode 3, and for DC charging stations, so mode 4, you're gonna need additionally at least MIC 2511 and a micrometer MMR 640. So let's say this will be like the minimum set.
Sure. I can add a point to here, as you rightly told. For the customer, it is more important to know what standards you are intending to fulfill. That is from the compliance requirements. So all the standards that you have mentioned before, this is the primary element of a customer who owns or who is involved in this kind of activity. What standard do I fulfill in my EV charging infrastructure? The second part will be the instrument. When we talk about the instrument, obviously the Indian standards do talk about the accuracy on having a compliance on 61557, which talks about the accuracy of an instrument. So keeping this to the third part, you can refer to 18732, the Indian standard, which talks about the instruments that is required in totality of an electrical infrastructure measurements, not necessarily in EV charging. So all the instruments that you've just mentioned is absolutely right. So on a conclusion, before we look into the instrument, it is more important and appropriate to know which standard I'm trying to fulfill for both from the compliance issue as well as from the safety issues. So Mr. Italat, I think more important is to fulfill the standard. Then comes the accuracy of the instruments. The next question will be whether electrical license or central state government certification is required to establish open charging stations. We are not the authority to comment here. Because to be frank with you, there are the legal complaints also changes from state to state. I mean, province, each state have their own requirements when you talk to the local distribution company. So we are not the company who will be in a position to advise it. The local distribution companies and the CAEG departments are the right authorities to comment on it. I think we shouldn't comment on the regulatory part here. Okay. Next question, please. Please give some. It's an anonymous. Please give some important guideline for installation of battery charger in residential area safely.
I believe this. So this will be about the design of the station, but. Here, we are talking more about the electrical test that the station should fulfill to be safe. So yeah, as it comes to the electrical part, it's all the same. So we are looking here at the CEA regulation, NEC, IS 17017, and the other international standards. So that's basically it. Now, if we were talking about construction, there may be some like distances limits, but maybe protections of the cover of the station itself. But yeah, we are just here referring to the electrical part.
You think we have guidelines on the installation of battery charger?
Yeah.
We have our own guidelines. I think it's easy to download from the BIS and all that, so you can download that. I think Narendra is saying he has a lot of queries, so he wanted you to touch base directly with Narendra. I think that you have in the list, so you can probably get it. Okay.
Yeah. I noted down his email address. We'll contact him after this event.
Yeah.
Okay, so there are 5 more questions from can we get more information about EV charging station testing and compliance without doing industrial visits or survey?
I think this is like my basic presentation on this. If I have more time, I can just talk more widely on each subject that I touched today.
Yeah. Maybe with more time, we will be in a position to give more informations. But without industrial visit or survey, maybe when we organize the next session only, we will be in a position to give more information. Let's get into the next question. How can we perform the calibration of inbuilt energy meter with EV charger? Do we have any solution for that? Mr. Hemant, this is a topic of calibration of the energy meters, which we do in Sonal India. We'll contact you separately after this call because Mr. Piotrik's session was majorly about the electrical safety verification. Regarding energy meter calibration, we'll contact you separately for that.
But I think when you build a new station, those meters come with a calibration, and then every certain period, depending on their manufacturer, you need to calibrate that. So yeah.
Okay. So one next question. There are two questions from Mr. Sushil. Is separate earthing mandatory for EV charging requirement? Do you need a separate earthing? And does EV charging, okay, and EV charging requirement need to be tested on a regular basis. So you have shown all this testing right now.
Yeah.
What is the periodicity of these testings that you have mentioned until now?
Okay, about the separate earthing, still it depends on the design. So sometimes, if you have a charging station on the side of the road next to some parking or right now on gas stations, you can see that they have pumps for gasoline, diesel, and next to that, a little further away, there are chargers for electrical vehicles. Then probably they would have some separate earthing. But on the other hand, when you have charging stations in the garages, they can be just or multi-story parking lots. They can be just connected to the earthings within the building. But yeah, this will be a question on the, let's say, construction of the charging station.
Okay. And how often do
Okay,
you
and does it
recommend to test the EV charging stations? Until now, the testing is what you mentioned. How often do you recommend to go for a testing?
Okay, I think there was 1 year.
Yeah.
Yeah.
So every year you are recommending to go for a testing.
I mean, we can look back into NEC how often to do the test, but I think typically would be 1 year. Maybe in some other situations more or less often, but
I've
typically that.
noticed some parts, some regulatory authorities were demanding, twice in a year, so on a periodicity of 6 months. So that is a requirement. We also have some questions from the customer who have raised the hands. Mr. Dominic, if you can allow them, or
No, I think that's the end of the question answer. There are so much of question answer. The curiosity is quite high in India. I'm sure you will also, Peter also would have been surprised so many questions coming up. I think India with 1.3 population and every purchase of 10 vehicle, 4 are EV vehicles. So which means 30%, 40% of the new purchases are on EV vehicles. So there's a potential that India in the next 2-3 years expected ratio of EV will be around 60 to 70%. So this important topic could be very useful to all of them who listen to this. I think we need to have after maybe 3 to 4 months, we need to have revisit the same subject. I think we'll have much more interest from other audience also. Over to Sham on concluding remarks.
No, it was a very interesting session. Thank you, Piotrek, for your insights. Thank you, Mr. Dominic, for organizing such a wonderful event with such large audiences for the event. We definitely had a great support from you in organizing such events. And also a good shout out to your marketing team who prepared all the great designs. Yeah, it was all very insightful designs, and I saw that you have tried to contact as many people as possible. In fact, in our physical presentation in Madurai also we invited some people yesterday. Yeah, so together we had a possibility to visit. So a great applause to Mr. Dominic and his team from Blue and Grey. Without your support, of course, this event would have not been possible. So thank you so much.
We have been doing so many knowledge sharing. This is a knowledge sharing, it's not about the company, it's not about the product. It's something that when such parameters or such equipment is available for testing, I think somewhere you save a life or you save a property
Yeah,
and you save an asset. So it's a very interesting that, I've been enjoying doing this webinar with Sonal because so much of information that we have been able to share. I think even the Indian standards are looking at it, and I got a message from BIS saying they're a wonderful session and such sharing knowledge is very useful from Sonal. So a lot of compliments coming pouring, and a lot of people. We had almost a 375 registration. Many of them said they regret that the timing was not suiting. Maybe next time we have to see whether we can do a 10:30. But Paul, Peter, you need to wake up at 5 o'clock to do that in case you want to have more attention or more, the thing. So let's see how we can figure out. Or
I
you may
have
have
my
to come
coffee
to
here, but
India. Yeah, you have to come to India and sleep for two 2 days and do this. Thank you so much, Peter. I know you have this weekend, Saturday. You are able to spare time, and very difficult for any European to ask them to attend or present on Saturday, which is a great weekend for you guys to with family and friends. But you're able to spend your weekend with our Indian audience who was so much
yeah.
curious and this thing. So your final comment, or did you enjoy this webinar, Peter?
well, yeah, of course I did, just like the previous ones. So thank you very much to everybody for coming here. Well, you also attended here on Saturday, so it's good that if we want to spend your time here on educating. I also am willing to spend my time to help you out and share the knowledge. So thank you very much for your time, for coming over here. And also thank you very much for active attendance and for all of the questions.
Thank you.
Yeah.
Thank you once again, Peter.
Shyam, another thank you for you to come out with the year-end message to the audience on this important topic, and I'm sure the kind of response that you got, you will make sure that you'll attend everyone who attended, and this
Sure.
recording will be available on the YouTube, so we'll share you. Which you can host it on Sonal, and also it is there on my YouTube channel. I'll be sharing to all of them. Those who are not attended also, it will be available for everyone to learn and understand and get back to you. I wish you all the very best to you, Sham and Peter. Happy Merry Christmas to you, and
Very
very
much.
Happy New Year to you and to your colleagues and friends in Sonal, Poland. Convey blue and gray wishes to you, and Sham, again, Merry Christmas and wish you Happy New Year. Your final wishes to my audience,
Uh,
Sham.
uh, Thank you. Thank you so much for the organizing again. And thank you for all the audiences who attended. A Merry Christmas and an advanced Happy New Year from Sonal team, from Sonal Poland team who couldn't be here, and also from Sonal India team. So good day. Thank you so much for your time.
Have a very great weekend, friends. We'll see you soon. Thank you. Bye bye. Have a wonderful
Bye.
weekend. Bye bye.
Thank you very much.